Hello, everyone. Thank you for joining. My name is Karan Singh. I'm a Director of Product Management in Oracle Cloud Infrastructure. I lead product for data services, including big data service, data flow, and data integration service in OCI. My co-presenter is Adi Samant. He's going to introduce himself when he starts presenting. All right, so this session is about migrating and modernizing your Hadoop applications on Oracle Cloud. And the key service we are going to talk about today is Oracle Big Data Service. It's a managed Hadoop service, which gives you elastic, scalable Hadoop clusters. It's a very interesting service. It has PaaS level features. It's a platform service, but it also gives you access at the infrastructure level. So it's very flexible that way. Oracle, we think that Hadoop is a strategic technology for Oracle customers as well as Oracle. So we have built a brand new Hadoop distribution from ground up, and we bundle that distribution as part of Oracle Big Data Service. And because we are creating this distribution from scratch, Big Data Service is the lowest cost managed Hadoop service across any cloud platform. So let's look at some of the key features, right? As we know, Hadoop is not a piece of software. It's not a single piece of software. It's a framework whereby a lot of typically open source projects, open source data projects, they come together to create the Hadoop stack. So what we have done with Big Data Service, with Oracle distribution of Hadoop, is to take the best of the breed, managed open source software, and we bundled it, made it part of our Hadoop distro. We have all the usual suspects in this space. We have Spark and Hive. Obviously, Hadoop and HDFS are there, and Yarn and Zookeeper. All the key components are there. But on the compute query engine, we have Spark, Hive, Trino. We have Kafka. Flink is coming out pretty soon. By the time you probably see this video, Flink will be out. But Tez and HBase. We also bundle Hue and Jupyter Hub and Uzi and Pig. So all these usual Hadoop components, the best of the breed, are there, right? Another thing we have done is made it ready for the enterprise customers. Oracle is an enterprise company. Our customers have high standard when it comes to things like security, high availability. So we have made that easy for our customers. The clusters can be containerized. For example, you can configure high availability to be part of BDS clusters from the get-go, so that if your master utility node fails, you can fail over seamlessly. The worker nodes, you typically don't have to worry because Hadoop architecture offers you that level of fault tolerance. But we give you easy to use patch management. If a patch is needed, it will show up in your console and you can choose when to apply it. We have bootstrap scripts. I'm going to show some of these features. I'm going to discuss them a little bit later. So I'll go at a relatively high level here, but there are many features that make it enterprise ready. We have integrated Big Data Service and our Hadoop stack into a bigger data platform in Oracle, which includes Lakehouse pattern services. So it integrates with our data lake service, object storage. It integrates with our data catalog service for external high meta store. It integrates with our data science service as well as OAC, the analytics cloud for BI dashboarding and analytics workloads. And last but not the least, many customers migrate into Big Data Service from an existing Hadoop cluster running somewhere. Opower, and Adi is going to talk about it shortly, is an example of one such customer that is migrating into BDS from an existing cluster. And we have made it easier for our customers to do migrations, like-to-like migrations, as well as upgrading Hadoop components. So we have created multiple versions of Oracle distribution of Hadoop. I'll call it ODH, or we call it ODH as well. In ODH, you can choose a more recent Hadoop stack or an older Hadoop stack. older Hadoop stack is version 0.9 in ODH. So, if you have been running your Hadoop clusters for some time and you're looking to mainly move your Hadoop clusters over and then modernize later, the kind of approach Eddie is going to talk about. We give you a version of older components, but if you have newer components or want to use newer components from the very beginning, you can do so as well. We offer cloud lift services whereby Oracle is going to help you with these migrations, as well as we have partners, both SI partners like Deloitte, as well as ISV partners like Vandisco that offer tools and services to make these migrations easier for you. Now, a key thing that we have focused on is to give you choices so that you can fine tune your Hadoop clusters to your application requirements. And this has price as well as performance implications. So based on that, because for example, your applications could be IO bound, they could be memory bound, or they could be CPU bound, right? And based on that, you can choose a different set of infra components. So you can choose different compute shapes, you can choose virtual machines of different types, you can choose bare metal shapes as well as HPC shapes. Bare metal shapes comes with its own local NVMe storage, so your IO performance would be really good. And as an example, on the storage side, we let you install or use HDFS on your local block volumes attached to your compute instances, or you can use local NVMe for certain compute shapes. But you can also, in the cloud, a good pattern is to keep your data in a data lake storage, object storage, or Oracle Lake, which is our recent service. You probably have heard about it during CloudWorld. But you can pick and choose any of these storage options. And networking wise, we give you a lot of flexibility to configure big data service within your networking stack, right? So if you're using OCI, you have virtual cloud networks. You can specify where do you want to run the service. You can tell us the subnets where you want to run the service. And the service is going to provision its resources within your network. So it's very flexible that way, and it can collaborate and coexist with the rest of the applications in your stack very well. And on the elasticity and scale, we have auto scaling features. We are going to talk about it shortly. And we also let you stop and start your clusters to save on cost, which is a very differentiated feature that we have. All right, so let's start looking at. We don't have enough time to do demos in this particular session, so I'm just going to give you a feel for what it looks like to be using this service. In terms of when you launch a cluster, you get to choose what kind of compute infra you want, right? And again, it shows some of those options here. So you could have chosen bare metal shapes or high performance computing shapes, or you could have chosen virtual machine shapes. This shows the VMs. And you can choose the Intel shapes, but you can also choose AMD flex shapes. Here you see that if you choose one of our flex shape options, you get to using slider bars choose the compute to memory ratio, right? So you can tune your compute resources very closely to your application requirements, right? And you can choose different type of machines. You can mix and match your master node and utility nodes and worker nodes to be different, right? And you can choose how much block storage you want to attach to each of these nodes as well. But the good things is in BDS, things are very flexible. So you can change these choices later on, either manually or using auto scaling as well. So a lot of flexibility. In terms of our security features, when you launch your cluster, you can just check a box that says give me Kerberos clusters, and we are going to configure your cluster that way. We let you configure your Kerberos realm names. So if you're using Kerberos or in your own realms and you have other applications in that realm, for example, you can reuse that with BDS as well, making it flexible. You can integrate with the external Active Directory so that you can use your existing identities in BDS, and you can also configure high availability out of the box. You just check another box and say, give me HA clusters. And now you have two masters and two utility nodes running. And you can, the failover becomes easy in case, the primary master or primary utility nodes were to fail for any reason. Okay. In an enterprise scenario, day one is good, but day two, when you're actually, have these things in action, that is also important. So we focus on operations quite a bit. One of the features there is bootstrap scripts. So you can provide a script when you sort of start a cluster, but you can also provide the script or change the script when the cluster is running. And what this does is when a new node comes up, either you set it up manually during startup, manually later on, or with auto scaling, a new node comes up, this script runs first. And once this script runs first, you can put anything in that script that makes that new node part of your application stack, right? So you can download and install any RPM, for example, or make any other configuration choices. That way you don't have to babysit your clusters, and it's much more automated the way your clusters and nodes come in and go out. Patch management, is another good operational thing. In Hadoop stack, if there is some new security bug or a new patch is required for whatever reason, you're able to apply that patch from within OCI BDS console. It will just show up and you can click that button whenever you are ready. And this service exists within OCI and are dedicated to cloud at customers. So it means that there's tighter integration with rest of Oracle services, including on metrics and alarms. So we give you a lot of metrics related to yarn related metrics and storage related metrics and compute related metrics right within the console, and you can get it at the cluster level and at the node level. And we also integrate with notification service, so you can set up alarms and get notified when something happens to your cluster that you want to know about in an urgent manner. You also get tighter integrations with Ambari, which is our management plane service, and not a service, I would say it's within BDS. So it's a feature of or a component of BDS, but you also get detailed metrics there as well. Okay, in terms of management, talking of Ambari, right? So this is a central place where if you are a Hadoop admin, you'll typically come here to do a multiple admin type of things. You can add new Hadoop components, you can start services, you can stop services, you can get finer grain detail into the health of your clusters. You can, because you have root privileges, you can actually log into the nodes as well. You can SSH into the nodes, only you have the keys. And in Hadoop, all these Hadoop components have different tuning parameters. So we give you access to all those parameters. So if you were to, in the left bar, if you were to click in Spark, for example, or let's say in this case, HDFS, right? You can then you can just change the parameters and tune the clusters to your liking. But we give you pre-tuned clusters, so it should work well out of the box for most of the use cases. And again, on the cost and performance, how do you optimize and tune the cluster to your requirements? Auto scaling is a key one. We let you scale horizontally as well as vertically. Horizontally is scale out and scale in. So you add more nodes or remove nodes based on the policies you specify. And vertical autoscaling is scale up and scale down. So to your existing nodes, you can add more cores. For certain VMs, you can step up to the next VM size, or for flex VMs, you can add more core and memory to the existing node. That's vertical autoscaling. So you can, two type of, you can do metrics-based autoscaling, whereby you write policies based on certain characteristics, and then you tell the rules and the thresholds of when that should happen, or you can do it on a schedule. You can say, hey, Saturday, Sunday, my cluster is not used much. So Friday, 5 p.m., 6 p.m., whatever, you make my cluster this size. And Monday morning, 8 a.m. before the work starts, make it that size. So you can do it on the schedule as well. We have introduced a new class of worker nodes called compute-only worker nodes, on which no HDFS data is sitting. So bringing in these nodes to do certain tasks quickly and then go away is a good feature to have. We call it compute-only work nodes that only work on tasks. And then, if you want to externalize the metadata from the cluster, you can externalize your data to sit in object storage or data lake service from Oracle. But you can also externalize your high metadata into data catalog based high meta store. And that can make your Hadoop clusters much more dynamic. They can come and go away. You can have more than one cluster. You can have clusters shut down and come up because your data is not lost. Your metadata is not lost. So it's a good pattern to have in the cloud. And you're able to manage the API keys for your data lake and object storage kind of integration right from BDS console. And the last thing I would say before I hand it over to Adi is cost is because cluster costs can add up. If you're using Hadoop cluster of any kind, maybe on-prem or in another cloud, you understand that pricing is a big factor in choosing a platform. And big data service with Oracle distribution of Hadoop is the best priced managed Hadoop offering in any cloud. We have done this analysis. This particular case, it's a 250 node cluster, and it shows the pricing across different platforms, and big data service comes out to be the best by a pretty good margin. With that, let me hand it over to Eddie.
Thanks, Karan. Happy time zone, everyone. I'm Aditya Samant, and I am Data Engineering Group Lead for Opower. Opower is one of the major product lines with Oracle's Energy Water business group. Opower's job is to take away any friction that stands in the way of its utility customers from taking actions towards being energy efficient, towards electrifying their transportation and heating equipments, towards adopting lower pricing, automating their devices, as well as helping low-income customers enroll in all the programs that help their energy make more affordable. When you are in the business of influencing and making an impact on utility customer action, you stand to make a big impact on the environment as well. And you can see some of the numbers which talk about the impact Opower has made over the years. 31.5, can go back to the previous slide, please. Yeah. So 31.5 terawatt hours is equivalent to what a Hoover Dam generates within 1 year. And it is equivalent to burning 16.8 billion pounds of coal. So it also has a decarbonization impact. Now, if you're going to have your products make an impact on hundreds of utilities, 175 over the years to be precise, and reach millions of customers on yearly, monthly, and weekly basis, then you need to have a strong architecture to back it. Let's go to the next slide. Opower's architecture is based in OCI completely. You can see some of the key elements over here. We have our utility customers sending over their ingest, and we also have utility consumers directly interacting with the web widgets we provide, and all of this gets uptake by the Opower architecture. There are multiple aspects of this overall architecture, but we specifically focus on the Hadoop platform or the big data platform, which is denoted as a data science platform in this picture. Let's move on to the next slide, please. This slide should be familiar for most watching this presentation. You have your ingest that goes into your Hadoop cluster. You will have a variety of processing going on in it. And from there, you are exporting your insights that you generated to a variety of products. For us, it's utilities, right? The utility data ingest is the big element of what we uptake. So that lands into MySQLs and Oracle databases for us, and from there it gets ingested into our Hadoop cluster. Similarly, we have streams of information coming from our web widgets, which also gets trickled into the cluster. Now, Opower's cluster has been a Cloudera-based cluster with all the usual suspects, as you see over here. We have Cloudera Manager, Ranger, Kerberos, TLS, Find, making the administrative layer and the security layer. And you have Uzis and Yarns and Spark, Impala, Hughes, CDSWs, the Cloudera Governance Workbench, all of this making the ecosystem around which our data is leveraged, so to speak. And we have two main use cases. One is the transformations of data. Another one is machine learning. I'm pretty sure you can relate to some, most, or if not all the components and the flows discussed over here. Let's move on to the next slide, please. So how big is this? We talked about 175 plus utilities over 15 years. So this platform reflects that. It's millions of customers. So we are currently on CDP 7.1.5, not for long, but that's what we are. We are two development clusters to production clusters. I don't want to read through all the numbers here, but our largest cluster is touching 100 nodes with about 5,000-ish CPUs, 50 terabytes of memory, about 1.4 petabytes of data in this cluster. So yes, definitely the big data scale. Let's move on to the next slide, please. Challenges, right? The main challenges we have with Cloudera has been with cost, right? It's a big cluster. The Cloudera has a per node licensing model. And we have 120 nodes that we license, each costing us about $10,000, right? That's about $1.2 million in pure licensing costs. You're not talking about anything more, just pure Cloudera licensing. Proprietary tech, right? Like we saw in the previous picture, we have Cloudera Manager there, Navigator, Data Science Workbench, Impala, all this tech, closed source, getting closed, more and more closed. And that's one of the challenges we have. And last but not least is, yes, we are part of the OCI stack. And one of the big challenges, our data needs to interoperate with more products outside Opower, outside of the Hadoop cluster. So that's where you will see more and more. That's where we want to see more of our value generated, where are the products of Opower interoperate with more products that Oracle has to offer. And that means our stack needs to interoperate more with other Oracle products. And we struggled with that, having a Cloudera-based system, which may not have the best interoperability with rest of Oracle's tech stack. These were the challenges we are having with Cloudera. So moving on to the next slide right here. All right, so here's the key word for you. How can you ace your migrations and modernizations of your Hadoop platform? Because that's kind of this presentation is about. We have this big ecosystem of on Cloudera, and how can you ace migrating off it? Here's our model. Maybe you draw a thing or two out of it. So we recommend a two-step approach: migrate and modernize. Your mileage may vary, but we'll talk about this approach. So what does ACE in terms of migration mean? There are three components to the ACE acronym. First is architect the whole journey, right? Many times we draw up this fancy diagram of pie in the skies of object storage and ephemeral clusters and Kafka streaming in, Kafka streaming out, and great, we all feel really good about it. But I would say, let's take a step back. Start with your current architecture. Have your first milestone architecture. secondary milestones, and don't be so particular about what your North Star is. Be flexible in terms of what it needs to be. Chart out your whole journey, not just from execution, but from an architecture standpoint too. And be flexible. Let's see where it goes. Architect the first milestone though, really clearly when you're migrating, and make it very close to what you currently have. Here's why. Cone of uncertainty. When you're going to make a move, even if it's as close to like for like, there is still going to be a lot of unknowns. You'll be adopting a new service. You'll be learning its behaviors. Even the service is going to understand how you're going to uptake it. To start with experimentation. So you'll have a lot of unknowns up front when you're working with anything new. So don't bite more than you chew. So focus on experimentation early on. Focus on getting your data right. Focus on getting your platform right. And one of the best ways to do that is put together your strongest single tiger team of sys folks, systems, platform operations, bring in Hadoop, add one or two Hadoop administrators, one or two data engineers, and get them in a room together with one or two BDS architects and consultants, and just go for it. Experiment, learn, fail fast. That's where you start. Don't bring your agile and scrum teams and plan the whole thing right away. Start with your best teams, get the first cluster right. And as you work through it, as you all learn as a collective, your cone starts to narrow, then you can bring in your customer use cases, you can bring in your scrum team, you can just accelerate from there. So that's your cone of uncertainty, make sure you respect it. So this is how Opower's target North Star architecture looks like. You can see incrementally we look to adopt more and more of services provided by BDS and OCI going to object storage, data catalog, and incrementally lessening our monolith Hadoop services. With that, I will transition over to Karan to conclude and take us through the rest of the BDS journey presentation.
Okay, thank you, Ali. So as Ali emphasized, right, so this particular Hadoop service coexists with many other data services, data and AI services in Oracle Cloud. Oracle is a data company. And there are many other services that can be used in a modern data platform, including your Hadoop stack, big data service. This just shows a lakehouse-based pattern in which you can bring in other services when you choose them, when you choose to bring them, right? You can keep your data in data lake. You can do machine learning using a data science service. You can use OAC. You can, for our analytics and BI and dashboard and reporting, you can use data catalog for data definition. You can use autonomous data warehouse, MySQL gateway. The idea here is that these services are tightly coupled, tightly integrated, but loosely coupled. So you can pick and choose the services you want to build the solution you want, which can be cloud native and modern. But if you want to mostly retain your Hadoop stack and not use other services, you can still build your Hadoop-based data platforms totally within Big Data Service. And as you start your Hadoop journey to cloud, Oracle engineers, Oracle architects, we are all here to help you. We have the partners ready to help you. So whether you just need more information or demos or do POCs or do real migrations with our cloud lift services, we are going to help make sure your migrations happen smoothly and quickly. With that, I thank you for your time.
Thank you.